Okay, let's continue the next exercise with the indirect way to prove if we have a model and non-logical consequences. So we made this just to prove that there is a model here and it's a logical consequences. So what if we don't want to do all of this? Because this is a very short exercise, but sometimes we'll find a very, very long and difficult formulas. And the best way is to save time because, well, I mean, I passed like some minutes here trying to prove it and making the true and false table. But now I'm teach you the another way, the indirect way to prove it. So first, we need to copy this and say for granted that there is a valid formula. So we have here the same P conjunction Q implication R, and we're going to put this symbol, which means logical consequences, which is P conjunction Q implication R. Okay, this is valid. Okay, so the first step, we indirectly suppose that this, or the same way, P conjunction Q implication R, is not the logical consequences. P conjunction Q implies R. This is the same, is not the logical consequences. That's really important. We supposed. So this is not a satisfiable. We prove that it is, but we are supposed just to get to the indirect way in order to find contradictions. Let me explain you more. Let's put one set. This set is going to be the same. P conjunction Q implication R. And another set, we are going to negate this one. Negation, this is really important. P implication in Q implication R. Now, it's not the same. If this is wrong, if there is no model, here we have a model. Because if there is a model, if here is not a model, here with just this element, negate this, we will have a model or a satisfiable, because we will have one here and one here at the end of the exercise. So here we have model row. Model and the symbol row. How can we prove this? So we can prove with the absolute value. If we put the same P conjunction Q implication R, all of this is equals to the row 1. By explanation, we can say that the next absolute value of this P implication Q implication R is going to be the absolute value. Okay, I put row 1, because remember, we don't have a satisfiable. That means this is incorrect. So here we have a satisfiable. That means satisfiable that the model have a 1 and 1 here. Okay, so let's make a tree value. If we put this here, let's divide this by 2. P, to get 1, we can say that P is the absolute value, rho is equals to 1, and this part, the absolute value of Q implication R, the rho is equal 0. Something is wrong here. Okay, yes. Okay, I went too long. Okay, we have 1. How can we get... Oh, and here is... Yes. I'm so sorry. We don't have 1 here. We have 1 is 0. Here we have 0. I'm so sorry, guys. Because here we have this represent to 1. And the opposite, without this, just this, we have a 1. That means P or 1 implication 0 get to the 0. That's the only chance. And well, we finish here. Here we have Q, the absolute value, rho implication 1, and here R, the absolute value, we have 0. That's the only way to get 0 here. Okay, so we finish at the moment in this part. It's really important to remember these elements. Okay, it's really important. This is our final result, but we don't finish the exercise. Let's do in this part, in this section. We don't change nothing. So in the case 2, this is the case 1. Case 1. And in the case 2, we're going to do this thing. The absolute value of P in conjunction Q, this is rho 0, or R, this rho is going to be 1. So first of all, P implication Q, it's equal 0. We have a little contradiction, because if we put, taking this P and Q, if we say P, which is the value of 1, and Q is equals to rho 1, because this we have put here 1 P, and here we have 1 and 1, this is 0. The same information, the same exercise here, as you can see, we have a contradiction. Because the same P and Q is equal 0, we have a contradiction. P and Q is equal to 1. So this is really important to remark. This is a contradiction. Now, in the case of R, we have here that is 1. But if you can check the same R, the value is 0. So here we have also a contradiction. That means this is a contradiction. And if this is wrong, that means this is satisfiable. It's a logical consequence, and it is possible to make one model unsatisfiable and logical consequences by the indirect form. Okay, please, if you have comments, send me your feedback, and also I want to thanks